Hi, I'd like to show you some of the new features in Shield Tracker. In specific, I want to show you today how modulation works in Shield Tracker. And so the first thing that I want to show you is just the built-in LFOs. And so for that, I'll start the sequencer. So now it's playing. And if you look on the right here, you can see these lines that are moving. And so these are visualizing 16 LFOs. And these LFOs are tempo synced, and you can program what they are doing. Now, before I show you how to program these LFOs, I'll first show you how to use them. So we'll start by creating a track with the poly sampler. So that one is a polyphonic sampler that plays stereo samples, and it can also act as a synthesizer. It has oscillators built in. Alright, so I'll create a pattern and I'll select patch 0 here, and now we can just turn up the volume of this oscillator, and we can add maybe a little bit of an envelope shape, and I can program a note, and I'll program a note off here. And once this pattern starts, we should hear a little bleep. Nice, okay. So I'll stop this for now. And so these synthesizer parameters, these live in the patch memory menu that you can see here. And when you press the right joystick, you get into the modulation setup. So this is what you can see here. And on the right, you can see what these different parameters are that we can map our modulation to. I'd start with pitch, because this one will be the most obvious to hear. So again, I'll start this pattern here, and I'll go into the patch memory. I go into the modulation page, and so now we can see we have these two modulation sources here, and they are currently set to modulators. So these are these built-in LFOs. And then we can select here which ones of these we want to use. So 0, that's the first one, and I can just increase the depth here. And so now we can hear the modulation that is applied to this LFO. Alright, so now in this pattern here, on the right we have these opcodes, and here we can program these modulators. So here the mod-s command, for example, which takes first a modulator index, which you can also see at the bottom of the screen here. You can see there's this, here is the description of the commands which tell you what these arguments are. So the first argument is which modulator we want to change, and then we can set a value for it. So here, this is the speed in steps. So now we have it in 4, so it's a bit faster. And then we can also change the waveform here, for example. So by default, it is set to triangle, but we can also set it to ramp down. Alright, and then there's like more commands, so we can reset the phase, for example. So like if we want to reset the LFO in the middle of it, and we can also set the amplitude of this modulator. If we go back to this menu here, like you can see that there are actually two modulation sources. So we have the depth here, and we have these two modulation sources. And we have a combine operation here, where we can decide what we want to do with these two modulation sources. So by default, only the first of the modulation sources is active, but we can also add or subtract the modulation from each other. We can multiply it, or we take the minimum or the maximum of these two. So for example, multiply is pretty interesting, because now we get the product of these two. So if we set this one to the next modulator, then what this will do is effectively fade in this other modulation. So I'll just start it again. And so you can see this is our modulator 0, and then the second one here slowly ramps up and down, and we can hear how it affects the depth of the pitch modulation. So I'll go on a little side quest, and so let's say we want to see what these modulators are doing, but when we are not on the main screen. So one of the features here is that we can add also graphics tracks, which I will do here. Like typically I just use the last one for that. And when we go to the patch memory of this graphics track, then we can select the shader index of this patch. So for example, here you can see the spectrum, and I think 0, 1, so that is the modulators. So you can see that these ones here map to these ones here. One thing that I haven't mentioned yet, so here is 0 for the modulators. So most of the modulators are only between 0 and 1, but you can also have bipolar modulators, so that's why it also extends to the negative, and the same here, so here would be 0. So if I start this, now we can see this animation here of these different modulators, and if I go into the pattern, then you can see that these background shaders are still rendered. And as you were briefly seeing before, like I can also select this background shader here, for example, which shows you the spectrum visualization of the master output of the tracker. If you want to select between different ones, you can just create different patches here. So let's do this and this one, and in patch 0 we can use the modulator output, and then here we can maybe use the spectrum. And if I now start this pattern, here you can see that it's switching between these two shaders. Alright, so I think that's enough for this little side quest. Yeah, so we still have the modulators set up. What else? So we also have the same kind of modulation settings in the mix settings. So here, if we go to the track settings page, here we also have this mix region, and if we press the right joystick, we get to the mix modulation. And one thing that you can see here, so I'm actually already using one of the more interesting modulation sources, which is the VU meter of the track. And so I have this track 0, this actually gets my microphone input, this is how you can hear me. And so I'm ducking the audio that is playing on this track by the microphone by a little bit. We can also do this the other way around. Alright, we are going back to the graphics track, so let's create another patch, and so let's I don't know which one exactly that is. Let's just start it. It's one of these images, and so if we now go to, oh sorry, I need to go to the mix settings here, so you can see the volume actually influences how bright the shaders are in the background, and so I could modulate this brightness by the track VU meter, for example. One thing that I haven't discussed yet is this depth parameter. So by default the depth is set to 80, and this maps to 0, and if you go to smaller values, this is basically -1. And so that means, so like now the VU meter of my microphone track is affecting the brightness, and the louder it gets, the darker it gets, and I can do it the other way around, that this image will only light up when I'm talking. So there's this little bit of background noise, that's why it never goes fully to 0. Alright, let's turn that off again, and we don't need that one again. and now we have our modulators back. Alright, we can also explore a few more of the modulation sources. So for example, I'll also turn off this pitch modulation now, and maybe the playback. So we have the modulators, but we also have an integration between the programming language that I will talk about in a different video. And if we go further down, we can see that we also have like some of the synth engine specific modulation sources. For example, we can map the filter envelope to pitch. And so if we program the filter envelope, excuse me, so like this. So now we should get a little bit of a pitch envelope. Yeah, so I will make it a little bit faster, and that was not very impressive. We're still doing this thing here, that's present. Alright, so now we have a little laser pew pew. Okay, let's do something a little bit more fun. So I'll create another patch, and let's create a little chord pad. So I'll start with this base node, and I'll use the chord memory function. For that we go into the track settings, and here we have these different pages. And we go to chord memory, and here we can just dial in a chord that we want to use in semitones. So let's add maybe this guy. Alright, so the chord now consists of 5 notes. And to use it, we go to this command column, and you can see here there's play chord memory in the column, and then the first argument is which note column. So note column 0 would be this one. Then we have note column 1 and 2 and 3. And then we select which of the chords. And so if I play this now, we hear nothing because I need to set up the oscillators first. Alright. So you heard that little click, and that is because we were re-triggering the notes. So if I play this multiple times here, you can hear like sometimes these clicks. If we want to sustain the note without having these clicks, we can just turn on this sustain pedal here, and now these clicks should be gone, and it doesn't re-trigger anymore. Alright, so let's use the modulation to make this sound a little bit more interesting. And so one thing this poly sampler synth engine has is these PWM LFOs. So we can set the speed of these LFOs, and each of the voices has their own LFO, and these LFOs track pitch. And let's go to the modulation page, and here we can see that we have some interesting parameters like panning, for example. So let's set this to PWM LFO, and if I now turn up the depth, so now you can hear that like these voices are flying around us in stereo. And if I go back here, we can set the speed of that one, like find a nice sweet spot, maybe a little bit less extreme, and let's make the sound a little bit more interesting. So here we have a ring modulator that uses both LFOs, and so we can turn this one on and add some brightness to the sound. Maybe not as much, like just a little bit. Something like that maybe. And what else can we do? Let's use one of these modulators. Let's just use modulator 0, and we can modulate the filter with it. So let's turn the filter down. Ooh. Oh yeah, we have the modulator already active. So let's select the modulator waveform from 0, and let's use ramp down and make it a little bit faster. So maybe, and then we can make it even faster, and maybe make it very slow here again, and can change the waveform here as well to back to, let's use one of the square waves. Okay, maybe it's a little bit too slow for this kind of thing. Okay, let's make it even faster here. Alright, what we of course also need is a little bit of delay and a little bit of reverb send. Alright, I think that's good enough for now, so let's just add another track. In the breakbeat track we can also have modulation, so if we go to the patch, and for example we could use the same modulator and modulate the volume of these different breakbeat columns. So let's do one positive and one negative, and I'll just make this pattern a little bit shorter. Let's add one here, and now we can add two different breakbeats here. And if I start this now, then we should hear that it's So now you can see that the modulators are being used to do essentially crossfading between these two breakbeats. Alright, let's say we want to add even more brightness to this one. One thing that we can do here is we can also do audio rate modulation of parameters. Let's go for this one here. So filter stereo, this one will offset the frequency of the left and the right channel. So if I select the oscillator 1 here, which is going to be a high audio rate of course, and then we can start to turn this up. Turn up the resonance a little bit. I'm not very excited yet. Okay, one thing we can do is use a more extreme waveform here. Maybe not the most exciting example right now, but I guess you get the idea. Alright, let's see what else is there for the modulation. Did we miss anything fun? Yeah, we can... Oh yeah, I remember. Let's do yet another polysampler patch. And so I'll do square wave, and I'll try to do like a little bit of a plucky arpeggio thing. So let's set this down, turn this one up a little bit. Of course we need to turn the oscillator up, and so if we want to program an arpeggio, we can just put a note here, use a table, and we can program our arpeggio here. So if I let's turn this one off for now. Alright, so this is like this very simple sound, and so one of the characteristics that make analog polysynth sound interesting is that they have some kind of variability between the different voices. So for example, they are like slightly detuned to each other, or like some of the envelopes might sound different if they are analog envelopes. And the polysampler has this per voice parameter as a modulation source, and here we can just dial in like kind of random values. So these are like one voice specific parameter. I'll just set it to something and try to spread it somewhat evenly. And again, like 80 is 0, and then FF is 1, and 0 is -1. Alright, so now we have this table set up here, or like, yeah, these values, and now we can, let's go for something extreme first. So we can take this voice parameter here and set it to pitch. So if so now you can hear like, so now like the voices are just like crazy out of tune, and but like you can use it like just in a very subtle manner, and we can also use this for the envelopes. So let's use the voice parameter, and so you can hear now there's like, again, like we should go for more subtle settings. So now you can hopefully hear that there's like some slight variation between these voices that is almost rhythmical, because you can hear this voice allocation in action. And now we can just drone it out in effects so that we don't really hear it anymore. But that's how it always goes, I guess. Since we're already doing tables, we can also add like a second table here and add like an additional arpeggio on top and like some kind of rhythmical variation. So let's maybe do a variation of this one here, and yeah, so like on a high level, this is how you use the modulation system. And as you can see, there's a couple more parameters here. We can modulate the position of the samples, the volume of the voice, and and yeah, for the sources, what else do we have? We have velocity. We have a global LFO that we can also use to modulate these global effects. A delay LFO. And when you're using the Steam Deck, so I'm currently doing this on PC, but on the Steam Deck you can use these touch controllers as modulation input. We have a noise source here. We can directly map MIDI CC values. And then we have like these three here. These are maybe a little bit more advanced. So there's a little programming language embedded in the tracker, and you can use that one to compute modulation on the fly, like for each voice individually. But I think it's enough for now, and I'll maybe cover these advanced features at another time. And yeah, with that, thank you very much for watching. If you have further questions about any of the features, please just write a comment. I'm planning to record a couple more videos on like some of the other features. For example, we very briefly used tables, and I haven't really described them. And obviously there's this whole business about this programming language that I haven't talked about at all yet. And I'm quite excited to show all of that. So yeah, thanks for watching. I hope this video is helpful, and see you in the next one.